Introduction to Chemistry. Chemistry is the scientific study of matter, its properties, composition, structure, and the changes it undergoes. It plays a crucial role in understanding the world around us, from the composition of the air we breathe to the functioning of our bodies. Atomic structure. At the heart of chemistry lies the concept of atoms. Atoms are the building blocks of matter and consist of a nucleus, composed of protons and neutrons, surrounded by electrons. The arrangement and behavior of these particles determine the chemical properties of an element. Periodic table. The periodic table is a fundamental tool in chemistry. It organizes elements based on their atomic number, electron configuration, and recurring chemical properties. It allows us to understand the trends and patterns in the behavior of elements. Chemical bonding. Chemical bonding occurs when atoms combine to form molecules or compounds. Covalent bonding involves the sharing of electrons, while ionic bonding involves the transfer of electrons between atoms. These interactions dictate the stability and reactivity of substances. States of matter. Matter exists in three main states: solid, liquid, and gas. The behavior of matter is influenced by intermolecular forces, temperature, and pressure. Understanding the properties of each state is essential in various areas of chemistry, such as thermodynamics and materials science. Stoichiometry. Stoichiometry is the quantitative study of chemical reactions. It involves determining the ratios of reactants and products, calculating the amounts of substances involved, and understanding the conservation of mass and energy. Acids and bases. Acids and bases are fundamental concepts in chemistry. Acids release hydrogen ions, H+, when dissolved in water, while bases release hydroxide ions, O. The pH scale measures the acidity or basicity of a solution. Chemical reactions. Chemical reactions involve the transformation of reactants into products through the breaking and forming of chemical bonds. Understanding reaction mechanisms, kinetics, and thermodynamics allows us to predict and control chemical reactions. Organic chemistry. Organic chemistry focuses on the study of carbon-containing compounds. It explores the structures, properties, reactions, and synthesis of organic molecules, including hydrocarbons, functional groups, and biomolecules. Inorganic chemistry. Inorganic chemistry deals with the study of elements and compounds that do not contain carbon. It includes the behavior of metals, nonmetals, coordination compounds, and materials with industrial applications. Physical chemistry. Physical chemistry combines principles from physics and chemistry to study the properties and behavior of matter. It involves topics such as thermodynamics, quantum mechanics, spectroscopy, and chemical kinetics. Analytical chemistry. Analytical chemistry involves the identification and quantification of chemical components in substances. It encompasses techniques such as chromatography, spectroscopy, and mass spectrometry. Biochemistry. Biochemistry explores the chemical processes and substances involved in living organisms. It focuses on biomolecules like proteins, nucleic acids, carbohydrates, and lipids, and their roles in cellular functions and metabolism. Environmental chemistry. Environmental chemistry examines the impact of chemical substances on the environment. It involves studying pollutants, analyzing water and air quality, and developing sustainable practices to mitigate environmental issues. Coordination chemistry. Coordination chemistry studies the complex formation between metal ions and ligands. It explores the structure, bonding, and reactivity of coordination compounds, which find applications in catalysis, medicine, and materials science. Quantum chemistry. Quantum chemistry applies quantum mechanics to understand the behavior of atoms and molecules at the molecular level. It helps explain chemical bonding, molecular orbital theory, and spectroscopic techniques. Thermodynamics. Thermodynamics deals with the transfer and conversion of energy in chemical systems. It explores concepts such as enthalpy, entropy, and Gibbs free energy, providing insights into the direction and spontaneity of chemical reactions. Electrochemistry. Electrochemistry studies the relationship between electricity and chemical reactions. It involves the understanding of redox reactions, electrolysis, and the use of electrochemical cells in energy storage and corrosion prevention. Materials chemistry. Materials chemistry focuses on the design, synthesis, and characterization of new materials with specific properties. It plays a vital role in the development of advanced materials for technologies like electronics, energy storage, and medicine. Polymer chemistry. Polymer chemistry involves the study of polymers, large molecules composed of repeating subunits. It explores polymer synthesis, structure property relationships, and applications in plastics, fibers, and biomedical materials. Computational chemistry. Computational chemistry utilizes computer simulations and theoretical methods to model and predict chemical phenomena. It aids in understanding molecular structures, reaction mechanisms, and the design of new compounds. Nuclear chemistry. Nuclear chemistry investigates the behavior of atomic nuclei and the use of radioactive isotopes. It finds applications in nuclear power, medicine, radiation therapy, and environmental monitoring. Forensic chemistry. Forensic chemistry applies chemical analysis to legal investigations. It helps identify and analyze evidence, such as drugs, toxins, and trace materials, to support criminal investigations and court proceedings. Green chemistry. Green chemistry aims to develop environmentally friendly and sustainable chemical processes. It focuses on reducing waste, energy consumption, and the use of hazardous materials to minimize the impact on the environment. Industrial chemistry. Industrial chemistry involves the application of chemical processes on a large scale for the production of chemicals, fuels, pharmaceuticals, and other consumer goods. It encompasses process optimization, safety, and product quality control. Analytical techniques. Chemistry utilizes various analytical techniques, such as spectroscopy, chromatography, mass spectrometry, and microscopy, to identify and quantify chemical components with high precision and accuracy. Safety in the laboratory. Safety is paramount in the chemistry laboratory. It involves proper handling of chemicals, following safety protocols, understanding potential hazards, and ensuring the well-being of oneself and others. Research and innovation. Chemistry research drives innovation and advancements in various fields. From developing new drugs to improving materials and understanding fundamental chemical processes, research pushes the boundaries of knowledge. Practical applications. Chemistry has practical applications in many industries, including pharmaceuticals, agriculture, food science, energy, environmental protection, and materials development. It touches our daily lives in countless ways. The future of chemistry. As technology advances and new challenges emerge, chemistry will continue to play a critical role in addressing global issues, such as climate change, renewable energy, and the development of sustainable materials and processes. Chemistry holds the key to a brighter and more sustainable future.